Hey YouTube, this is Jim Neeb from Jim Neeb Woodworks again. Um, I noticed a problem when I was making some measurements on my new laser beam width. I had a series of lines that I had scribed very close to each other to try and gauge the width of the laser beam itself, and noticed that the start and stops were not aligned between the lines as it was zigzagging back and forth. And it occurred to me that I had never actually calibrated some of the axes on my CNC when I got it about two years ago or so. So I had trammed the head and squared the X and Y axes and all that. What I had not done is fine tune the XYZ axis travel as far as accuracy in travel, and I had not measured or adjusted the backlash in any way. So I'm going to do a couple of videos on how I did that. This first video here is just how I measured and tuned the X, Y, and Z axes to get an accurate travel, between what Mach 4 says and what actually resulted in the movement of the head. So that's what this video is about. So this is a setup I'm using to measure the x-axis travel accuracy. It's just a 1-foot digital caliper. I don't have a long, 1 meter long or so precision ruler like a lot of people use for this, but I did have this 1-foot caliper. This actually works pretty well. So I just clamped it down on the z-axis above the bed a little bit, as you can see. I'm going to move X back to a starting position, and then I'm going to go a little bit to the right because I want to take any backlash out of the drive that can be there. And then I move the caliper down to that point and zero it. So I have the axis set up. The caliper has been zeroed out. You can see there. And it's ready to move. I'm going to run an MDI command here to move the x-axis over 9 inches exactly. I have the x-axis zeroed out as well. So when I run this, the x-axis will move over exactly 9 inches. And you can see it moving over here. And when it stops at 9, what the caliper says will not be 9 because there is error. It says 8.988, so I'm about 12 thousandths short of what the CNC. So now I'm going to go into my motor settings, configure control, motors. Motor 0 is my x-axis, and so 4077 counts per inch is my current setting. Okay, this is the last verification run. I've kind of bounced back and forth to find the most optimum value for this 9-inch move. And this is the third run I've done just to see what the variation is. The first two came out exactly to 9.000, and this one's half a thousandth off, which is just fine for this machine. So I think I've got it. So as you can see, I ended up with a value of 4,082 steps per inch. The original that came with the machine in the AVID CNC configuration was 4,076. The theoretical value is 4,074.36, but there's always slight variations in machining and stuff like that cause the ratios to be off a little bit. So this 4,082 steps is the value that comes out to give me the most exact measurement I can actually get on this machine. And now I'll just repeat this with my Z and Y axis as well as my rotary axis, my A axis. So oddly enough, the y-axis is perfect already with the old 4074 number. So this just shows that every axis is a little different, and if you really want it fine-tuned, you have to go through and measure each one. The step counts, even though the motors and the gear drives and everything are exactly the same, there's still slight differences. Okay, for the z-axis, I don't have a good way to use the caliper because it's harder to mount vertically, so I'm just mounting a dial indicator, and I'm going to make a small travel of about 0.8 inches with this, but that should be good enough to tell me if I'm good enough or not, since I don't usually Z up and down that much. It's not as critical that it's accurate over 50 inches or so. So you can see from this, I'm only about 1.5 thousandths away. That's not too bad, but I'm going to see if I can dial it in a little bit better. Okay, after dialing in the z-axis counts, I had to add about 10 or 15, I can't remember, but that 1.5 thousandths off in 800 thousandths travel is now corrected, so I can repeatably hit exactly 800 thousandths now on the dial indicator, so I'm pretty happy with that. So after measuring my X, Y, and Z, my X was in 9 inches, was short about 12 thousandths initially, and I corrected that. Y was good, and Z was off about 1.5 thousandths in 800 thousandths, and I also was able to correct that easily. So now I have my axes all within about a thousandths, at least within the capability of my measuring equipment. So that's quite a bit better than it was out of the box. So now I'm going to try to measure backlash on my system. I'm going to start with the x-axis, and what I have here is a dial indicator that my x-axis, or the side of my z-stage, can bump up to in the x-axis. And what I'm going to do is have it go 0.4 and then another 0.4 inches back and forth, stopping in the middle of the travel. So start at 0, move right to 0.4, move right to 0.8, and back to 0.4 and back to 0, with some delays in the G code so I can watch where it ends up. And the difference of where it lands going in the right direction at 0.4 versus when it comes back to 0.4, that's basically the amount of backlash I have in my system. And so Mach4 lets you program a value in there to try to compensate for that. That's basically there because of slop in the gear. Okay, here I'm going to measure backlash on my y-axis. So I've I've moved y into the dial indicator, and I'm going to set the y-axis to 0 on the Mach4. So you just set all the axes to 0. So now I can move back, and then I use the go to XY 0 here, which will bring it right back to that same spot. And now I want to fine tune this again, but as you can see, I don't need to. So now what I'm going to do is move out in just a little bit more, just with the controller, and then go back here again and say go to XY0, and that moves it back, but it came in from the other direction. So as you can see, there's just a little bit of backlash here, only about a half a thousand, so that wasn't too bad. I had about 2 thousandths on my x-axis. This isn't bad, but I'm going to try and adjust it anyway, just for the fun of it. Okay, I want to adjust my backlash about a half thousandth, so I'm going to go to Configure, Control, and Motors. But first I'm going to double check my axis mapping. I'm doing my y-axis right now, and you can see my y-axis actually has 2 motors, one slaved in. I have one on each side of the gantry, so I need to do both motors, make sure I do both. So it's 1 and 3. So I go to motor 1. I'm going to put in half of the thousandths, hit apply. Don't forget apply, because it'll erase that if you move on to another one and don't apply it first. Then I'm going to go to motor 3, hit a half a thousandths as well, hit apply, okay, and then I haven't homed the machine, so get some junk there. And then the other thing you want to double check is with the Ethernet smooth stepper that is used on the AVID CNC machines, you want to go into the plugins, into the ESS driver or plugin, and just check the backlash and make sure that the use backlash compensation checkbox right there is turned on. The settings, the amount of backlash that you want to set comes from the control window of Mach4, but the smooth stepper is the one that actually performs it, and it needs to be checked here. Otherwise, no matter what you put into Mach4, it just ignores it. So, and then all of these settings are just reads from Mach4. It's really only just turning it on in here that matters. So that's it. Now save it, and then we'll try and see if it made an improvement. This doesn't really substitute for really sloppy mechanical systems, so if you have just a couple of thousandths, that's probably as good as you can do on a system like this with rack and pinion drives. But if it was significantly worse, you'd want to go clean up the mechanical problems first. But just for a couple thousandths of an inch, this seems to work pretty well. Just as a side note, this machine came with the acceleration set pretty high. Mine has a 4-foot gantry with a high 12-inch Z-axis, so there's a lot of weight on it, especially with the 3 horsepower spindle. So I think it was at 1200 for max velocity, and acceleration was 150 or something like that. Yeah, that works fine for if you're making long cuts, like cutting out panels or something, you know, where you're not making a lot of quick, sudden turns and stuff. But if you're doing a lot of V-carving where you're going up and down, and especially X and Y rapidly around small letters, the whole system starts to shake and vibrate a lot, and you start to get kind of chattery cuts on your V-carves and stuff. So I'm not in production or anything, and quality of cut is more important for me. So I turn my acceleration down to about 25 on all my axes, and I get much smoother results with that. And honestly, for small movements, you don't really accelerate up to maximum speed anyway. So this just smooths things out, and most of the jobs that I actually measured the time on didn't really significantly slow down to do this. So I definitely recommend playing with your system to see if acceleration helps you. Okay, again, I've moved into this position from the outside. I'm going to step in a little further and come over and hit go to XY. Now we'll see if that improved things. So you can see I'm pretty much landed right on 0, so I'm pretty happy with that. We can again move out, go to XY0, check it again. I'm just below the 0. Move it in a little ways. XY0 again, and you can see it's just a little bit under 0. So basically it's coming back to that same exact spot from either Y direction on the indicator, and that's what you want. Basically, we've removed backlash out of this again. Okay, finally I'm going to set the backlash adjustment on my Z-axis, and this, I just turn my dial indicator to point up into my back plate of my Z-axis. There isn't a go to Z-axis on Mach4, just X and Y. So instead of doing that, I just simply wrote this G1Z0 command in the MDI window, and so that basically will do the same thing as the go to Y button up here did when we did the X and Y axis. So this works just as well, and basically same thing, come in from either side multiple times and then adjust the software setting until you get the same result from either direction. Okay, I just got done measuring it, and I had about a half a thousandths on the Z-axis as well, just like the Y-axis. So I went ahead and added it, and now you can see it's landing right on 0 from both directions. So I didn't mention before, but unlike Mach 3, where every time you make a setting on these motors, you have to exit Mach 3 to have it saved properly. You don't have to do that on Mach 4. I found out it takes the values fine without having to exit. So it makes the process a little quicker. But okay, that's it. That's a pretty easy way to set your axes backlash down to 0, so that when you're especially for rastering, this is pretty important. If you're building 3D models like carvings that have a lot of kind of slopes and stuff to them, if you don't have your backlash adjusted very well, you'll see these slight little lines or stripes in the carving because you're going in opposite directions on every adjacent pass, and it sands out okay if it's only a couple thousandths, but if it's much more than that, you can definitely see it, and if you finish it without sanding it out, you'll really see it then. So this really fine-tunes it nicely, so it gives you a good control from all directions. So one other problem you might have sometimes, depending on what speed you're trying to run and how heavy your gantry is and your software settings, is losing motor steps. And so I wanted to change my microstepping counts to see if it could improve another problem, but I wanted to make sure that didn't cause problems, increasing losses in steps or introduce a problem with losses in steps, because I don't really have a problem with that right now. So what I did was I just locked down my touch plate up here in a corner of my table, and then I created just kind of a dumb program that does a whole lot of XYZ moves all over. It's basically doing some plunge, small shortcuts. So it's plunging a lot and moving in X and Y a lot, and it runs for about 20 minutes. And the idea was to move the head around with a lot of movements, and if quickly to try and see if it would introduce any step losses in the steppers. And then I would come back and reuse the touch plate and see if anything is lost. So I home the whole system first so that the machine coordinates are set, and then I obviously use the touch plate to get X, Y, and Z zeroed out. And then I run this long program. Well, before I run the program, I record the machine coordinates. So if you go onto Mach 4, normally these are showing your work coordinates, but if you go to switch to machine coordinates, which is showing 0 right now because it's zeroed out, you can get the absolute coordinates on the whole machine. Mine are showing 0 because I didn't home the machine, but this number won't change if you lose steps, but when you use work coordinates and you re-zero out X, Y, and Z with the touch plate, they will change to the new position of the head if motor stepping points are skipped. So what I do is I run the program, I come back in here, and I rerun the touch plate program, and when it gets all done, it parks the head in a certain spot. And then I switch over to machine coordinates, and I just compare the original machine coordinates at that spot from when I first ran the touch plate program to when I ran it again after this long exercise of XYZ movements happened, and compare the differences. And they should, the repeatability of this touch plate in my systems, about 1/1000th of an inch pretty regularly. So, I didn't want to see any movement beyond that. Otherwise, I would be worried that I'm losing stepper steps, and I didn't. But I think this is a good way to check. It's obviously not worst case. You can always have long programs that really pound an axis. I've had some that run for 15 hours, and you might not see anything with a short program that's only 15 minutes like this, but at least I was able to catch anything gross, I think. So anyway, that's a good way to see down to a few thousandths if you're missing anything without actually having to go cut test pieces on wood or something. Okay, now is the moment of truth. So we adjusted all of the X, Y, and Z parameters, backlash, accuracy, and everything to the best that I could. So here's the original cut that got my attention, especially on what I did was I spaced these lines on the bottom one 0.01 inches apart and the top one 0.015 inches apart, and the point there was to try and tell what the width of the laser beam was, so you can tell it's somewhere around 5 to 7 mils, which is about what was advertised by the manufacturer. But you can also tell, especially on the 15 thousandths of an inch one, that the start and the stop on those ends is not the same spot. And again, I was wondering if that was either due to the laser starting and stopping differently, or if it was the backlash on the x-axis. And it turns out when I did my backlash measurements, my x-axis was the worst, in fact, and that's what these lines were cutting on. So now if we go up to the ones I just cut after adjusting everything, hopefully you can see it on here. They're so small you can't see them very well with the naked eye, which is what you would expect. I only found about 2 or 3 thousandths of backlash on my x-axis, but you can see that these are actually straight. They're in a straight line now, both. Hopefully you can see on the camera. I can see it, but they're lined up nicely now. So it was not my start and stop of the laser, which I didn't really suspect, because the laser can really start and stop quickly, and I'm using M62 and M63 commands and G-code, and those are intentionally made for synchronizing with motor movements, so it should have been very well aligned through those commands. And so the actual cause of this was backlash in my x-axis, and now it's very, very well aligned here, so I'm very happy with that. So hopefully this was helpful for all of you. If you have any questions or feedback, please leave them in the comments. Thank you.